All right, math fans, welcome back, and let's finish off graphing parabolas in this form. All we need to do yet is look at the form where we have y equals ax minus h squared plus k. And here, when we're looking at this plus k, we're looking at up, down for vertex, right? So we're looking at up, down for vertex. That's kind of what we're putting together here. All right, so when we think of these examples, let's take a look. Let's look at example 1, now that we're including the k component of the vertex. So we're going to graph f of x, y equals f of x, right, function with variable x, equals 2x minus 1 squared minus 3. And we want to state the major features. Well, first off, right away, the vertex is going to be 1 and 3. And I'm getting that 1 from there and negative 3, from the end there. So I know I'm going to start my table values at 1. Or like that's going to be the middle of my table values. Okay, so 1, 2, 3. That's 1, 0, negative 1, negative 2, 2, 3, 4, and then this will be f of x. So 1 will be 0, that would be 1 and negative 3 there. Let's do 2. 2 minus 1 is 1. 1 squared is 1 times 2 is 2. Minus 3, negative 1. Good. And this is increasing since it's positive up front, so this is good. Opens upward. 3, that's 3 minus 1, that's 2. 2 squared is 4. Times 2 is 8. Minus 3 is 5. That's good. And the next one, 4. 4 minus 3 is 4 minus 1 is 3. Squared 9 times 2, 18. This is 15. And by symmetry, I have that on the other side here as well too. And the points grow faster as well too. Good. So let's get this on a graph. Let's get this on a graph. Putting it together, let's get something that we can get a lot of values for. And there's 1. And there's the other axes, x, y. All right. And our first point here is at 1 and negative 3. We have 0 and negative 1 as another point. 2 and negative 1 as the other. 3 and 5. 1, 2, 3, 4, 5. Right, these are my xy pairs. And then negative 1 and 5. Negative 2 and 15. So let's add 8, 10, 12, 14, 15 right there. And then by symmetry right there as well too. Right, and we can identify the axis of symmetry right here, right? And then any two y points are separated by the same distance on the axis of symmetry. Good. So when I do this, I'm just making a rough sketch of the parabola here. Comes back around the corner. Up we go. Just like that. Look, we're making it. And this one should actually be kind of sticking out like that. That's it. So key features, what we're looking at. So vertex, 1 and negative 3. When we're looking at this too, axis of symmetry is just happening at x equals 1. Right, we have that there, the green dashed line. X-intercept, let's calculate it out. So here, this is y equals 2, x minus 1, squared minus 3. I set y equals 0, set y equal to 0. Then I'll get 0 equals 2, x minus 1 squared minus 3. Add 3, add 3. I get 3 equals 2, x minus 1 squared. Divide by 2, divide by 2. Get 3 over 2, x minus 1 squared. Square root this, square root that. And I'll get x minus 1, just changing it around, plus or minus root 3 over 2. And this will be x equals 1 plus root 3 over 2. And the other one will be equal to 1 minus root 3 over 2. So I get two x-intercepts that way over here too, right? So you could estimate it as well. It looks like it'd be 2.2 and minus 0.2. All right, y-intercept, that showed up nicely. The y-intercept here was just 0 and -1, right? That showed up in our table values really nicely. It should show up in yours. Domain here was x is all real numbers, or it's going from -infinity to infinity, or you could say x is bigger than -infinity but less than infinity. Range, so this was opening upwards. It had a minimum, so this means y has to be bigger than its minimum. Its minimum was the y component of the vertex, so -3. Y always has to be bigger than or equal to -3, or with interval notation, -3 to infinity, like that. Then finally, it had a minimum, and that was at y equals -3. And it opens upward, right? Opens up. And those last three, the range, the minimum, they're all related. Okay, let's look at the last example. So example 2, right? Same idea. Let's see what's going on. Y equals -1/2 x plus 1 squared plus 2. And x values, f of x, we know we're going to start at -1 for our middle. -1, 0, 1, 2, 3. -2, -3, -4. Let's start here at -1. That's 0, so that'd be -1 and 2. I know this opens downward because of the negative in front, so all my values from this point should be decreasing, right? This vertex is a maximum, right? That's a maximum there. Okay, 0 plus 1 is 1. 1 squared is 1. -1/2 plus 2 is 3/2 or 1.5. Okay, 1, that's 2, that's 4. 4 divided by 2, -2 is -2, plus 2 is 0. And so let's just have symmetry here too. 2 squared is, that's 3, that's 9. 9 divided by 2, 4.5. -4.5 plus 2 is -2.5. So this is -5 over 2, or -2.5. This would be -2.5. And then if we did the 3, actually, let's go back and do this. I knew I wanted to do it on that side. 1, 2, 3, 4. 1, 2, 3, 4. If we have -5, -5 plus 1 is -4. -4 squared is positive 16. Divided by 2 is -8. Plus 2 is -6. That'll be -6 as well too. Good. So we can see a nice decreasing pattern here. Let's get a XY axis on here. And right there. X, Y. Start with our vertex, -1 and 2, right here. And let's just graph the points that are right on there. So 1 and 0 is going to be on there. And -3 and 0 is going to be on there. -5 and 6, 2, 4, -6. And then 3 and -6 as well right there. And we can fill in the points that we're missing. So this one is 3/2, 3/2. And this is -2.5, -2.5. Roll this out. Perfect, right there. Roll that out. Oh, that should actually be on there. That should be on our y-intercept there. Excuse that. Oh, it looks like we're going to get the x-intercepts for free. All right, let's get our stuff here. Vertex, this is -1 and 2. Axis of symmetry, right? That's just the x component of the vertex, so that is x equals -1, right? Everything is equal distance. All our y values are equal distance from -1. Right? They're symmetrical. X-intercept here, when we're looking at the x-intercepts, we got them for free here, right? 2y, 0, so we're good there. So I have one at -3 and 0, and I have one at 1 and 0. You could do the calculations on it. You could do the algebra, and I actually encourage you to do that just so that you can take a look and verify that doing the algebra would give you the same solutions. So take a moment to pause, try it out. All right, welcome back. Let's take a look at the y-intercept. So that's 0 and 3/2, or you could say 0 and 1.5. Let's take a look at domain. So domain here, domain, this is just going to be all real numbers, right? We're going to get all the numbers out of this. It's going from x is bigger than -infinity, less than infinity, or it's going from -infinity to infinity. Our range, we're at a maximum, right? So this is a max. Max is y equals 2. So that means all our y values are less than or equal to 2. Or we could say our y values go from -infinity all the way up to 2, just like that. Good. So this is everything that we've done so far. We will take a look at putting it all together in the next video and continuing from there. Have a good day.